We're going to introduce the idea of derivative, and I'm going to give you the first rule when finding derivatives. Right? When we look at calculus and we kind of examine what calculus is all about, your first half of your calculus course is probably going to be all about derivatives, and your second half of calculus is probably going to be all about integrals or antiderivatives. So the idea of a derivative is a really important idea. This video is not going to explain what a derivative is. I'm not really even going to define it formally. What I am going to do is introduce to you the first trick, the first rule that we'll use to find derivatives. So first things first, you're going to be introduced to a polynomial. Let's say it's this. And you're going to be asked all throughout calculus to find the derivative denoted by the prime, f prime, f of x. F prime is the derivative. All right, sometimes you'll just read it as, you'll just see it as f prime. All right, so to find the derivative of this trinomial, you're going to look at each term individually, and you're going to utilize your little power rule. Power meaning, of course, exponents. So when we take a look at the power rule, it is basically examining this exponent, multiplying it by the coefficient. 7 times 2 is 14. Keeping your variable there, and then reducing that exponent by 1. 2 minus 1 is 1. Alright, as you know, we don't need to actually write exponents of 1 in math, so we won't. Deal with the second term separately. So we take our exponent. Believe it or not, there's an exponent here of 1. So we take that exponent and we multiply it by the coefficient. So it's negative 6 x. So you always rewrite the variable and reduce that by 1. 1 minus 1 is 0. Now the beauty of this is anything to the 0 power is 1. So we actually don't need to write that variable. It just kind of disappears. So 6x, if the derivative of that, if it were just on its own, is literally just 6, or in this case negative 6. Alright, positive 8, that's a constant. The derivative of every constant is 0, so that doesn't, you don't need to write that. It just kind of like disappears. So the derivative of f of x, in this case 7x squared minus 6x plus 8, the derivative of it is 14x minus 6. It's that simple. Let's try one or two more here. Example 2. Let's do negative 3x to the 5th plus x to the 16th plus 2x to the negative 4. Alright, so we take f prime of x, and we're going to take 5, and we're going to multiply it by negative 3, which is negative 15. Rewrite x, reduce that by 1. Beautiful. Next, we're going to take the exponent 16, multiply it by the coefficient in front of x, which there isn't one kind of visually there, but we know that there's a 1 there in front of the x. So it's 16 times 1. Rewrite the x, reduce the power by 1. Alright, lastly, this gets multiplied by negative 2, so that gives us negative 8x, and then reduce that by 1. Be careful, negative 4 minus 1 is negative 5. Common mistake there would be to put a negative 3 right there, but it's not true. And a lot of times what you'll be asked is to put them in a nice order, so you go try to get them into standard form. So you want your biggest exponents first and your smallest exponents last. And what you also might sometimes do, if you depending on the exercise, but you're aware that the exponent rules still apply, so this one can actually be the negative exponent is attached to the x So it's x to the negative 5. That actually makes it go into the denominator and becomes a positive 5. So the 8 has an exponent of positive 1, so that stays in the top. The x to the 5th can go down to the bottom. All right, that's kind of like not the most important exercise here. The most important exercise is understanding how we get this right here. All right, that's really, really important. Understanding how to get from the regular function to the derivative. So that's the power rule. Next up, we'll do chain rule, product rule, quotient rule, and then talk about some other shortcuts with logarithms and natural logs and exponential functions that kind of look a little different, and kind of go from there.